All right, so we should have a really quick note section today because our objective is to convert between the standard and factored form of polynomials, which is exactly what we did on Friday, but now we're going to include instances with multiplicity. So let's quickly define what that is, see how it shows up. Multiplicity is simply how often a certain zero, root, or solution shows up. We'll see what this looks like in an equation in a bit, but on our graph, here's kind of our three different types we're going to see. If you look at this first red graph, multiplicities of 1, they're going to cross the x-axis normally. This is kind of what we normally see when we're working with stuff. Notice how this just crosses through, this just crosses through, this just crosses through. There's 3 zeros, roots, or solutions, but they just pass through our x-axis like normal. If you look at our even multiplicities, they are just going to touch the x-axis. So we have one here that just touches that crosses through. That's not going to have any multiplicity. That's just going to be 1. But if you look at right here, this graph kind of bounces off the x-axis. This has a multiplicity here. Okay, notice the difference between the line that crosses through like normal and the line that bounces off of our x-axis. Okay, and then odd multiplicities, they're also going to cross through the x-axis, but they're going to flatten out a bit. So notice in this last one here, this odd multiplicity, there is no normal one. This odd multiplicity flattens out and then jogs down. So there is a multiplicity here as well. So let's see how these show up in a couple different ways. The first way is when we're writing our functions or equations. So if a zero root solution has a multiplicity, we're just going to rewrite it that many times. So we're going to write a possible functions with zeros at 2, -4, and 7. And those multiplicities have 1, 2, and 1. So I'm going to start. I'm just going to write out my function notation. So f of x equals, and I'll start with this blue one here. We'll start with 2. So we have, if the 0 is at 2, we have a factor at x minus 2. If the 0 is at -4, we have a factor at x plus 4. And since that has a multiplicity, that is going to show up twice. X plus 4, x plus 4. And finally, we have 0 at 7, which is x minus 7 for our factor. And that only shows up the one time. So that's one way to write it, but we can also write it a little more condensed down, where if I take this, I do the same thing I did, f of x equals x minus 2 times x plus 4. Another way, instead of writing that twice, is to use an exponent, which creates a nice and short, or a much shorter equation that we can work with. Let's try this for example 2, because there's a couple things to throw us off. First thing I'm going to do is I'm going to write my function notation. And I'm going to, from the start, just use my exponents because it'll be a little easier. I'm just going to start with this x minus 5. X plus 5, because the 0 is at -5. And that's going to have a multiplicity of 3, so that's going to be raised to the 3rd power. Let me skip this 0 and come back to it. And then I have a 0 at positive 3, so my factor is at x minus 3. That is a multiplicity of 1, so we don't need to write the exponent. Now remember, if we have a 0 at 0, that's going to result in an x out in front, and since it has a multiplicity of 2, that is going to result in an x squared. Now notice that if you added up all these multiplicities, 3 plus 2 plus 1, this gives you 6. Well, that also matches the degree of our polynomial. We have 2 x's here, 3 x's here, and 1 x here, where we should have a 6th degree polynomial. All right, lastly, we are going to continue our work from Friday, where we are converting from standard to factored form using graphing. So in example 3, we get our function at x equals 2x to the 3rd minus 6x squared plus 8. Let's go through this process. We're going to plot the standard form of the function in Desmos. So I got that in here. 2x to the 3rd minus 6x squared plus 8. Then I'm looking for the zeros. So if I look at my zeros here, it looks like they happen at -1 and 2. I'm going to write those out. Zeros at -1 and 2. And right away, I should know that, hey, I'm expecting 3 zeros, expecting 3 because we have a degree of 3. So that means that if I have 2 and I'm expecting 3, one of them needs to show up twice. Let's look at our graph and see what's going on. We have this first one passes through our x-axis normally at -1, so that's just going to be a multiplicity of 1. And this second one here, the 0 at +2, it just glances off my axis. So this is going to have a multiplicity of 2. Let's go back and kind of jot that down. This one here, this has a multiplicity of 2 based on that graph shape. So if we're writing the function out, let's start it here. F of x equals, we're rewriting the zeros as factors and we're finding those multiplicities. Okay, f of x equals x plus 1 times x minus 2. And notice that if I were to just type that in as normal, let's add a new expression, equals x plus 1, x minus 2. I'm hitting the zeros correct, but my shape is all sorts of off, right? My end behavior is off. I only have 2 crossings. And so all we need to do is add that squared to the second 0. You might have noticed my graph shape isn't quite perfect yet, and that's because we need to account for that leading term, right? Notice how we have a stretch there, and that leading term out in front of our standard form is 2, or that leading coefficient, so we just need to throw that 2 in front of our factored form as well in order to get that to match. And that should be our answer because it matches on our graph. Now, let's do one final go here. Example 4, negative x to the fourth minus 8x to the third minus 18x squared plus 27. So right off the bat, I'm knowing that my degree is 4. So I should expect 4 zeros. Degree is 4. So we should have 4 zeros. Yet, if we plug this into Desmos, we can delete our old one. We can close this one out, add this one up. It looks like I only crossed my x-intercept 2 times, once at -3 and once at 1. So let me just write these down real quick. We have zeros at -3 and 1. But again, if we look at that graph, this -3 crosses, but it kind of flattens out first. So this is going to give us a multiplicity, and we know it's got to be an odd multiplicity because it flattens out. And we know if the 1 only shows up once, then this has to show up 3 times, mult of 3. So if I write my equation, f of x equals, we'd have x plus 3 if it shows up 3 times. We go to the third power, and x minus 1. And the final thing we should account for here is we have this negative sign out in front of our equation, right? So we want to make sure that that goes in front of our equation as well in factored form. So I'm going to go back and just test this graph real quick. Add an expression, we type in f of x equals that negative. Here's x plus 3 to the third power times x minus 1. And if we look, I'll clear out my scratch work here. Nice, that does seem to match between the red and the blue, so we are good to go.